Welcome to the Reliability Center Maintenance, or RCM, Culture Evolution presentation given by Don Berry of Asset Acumen Consulting. This is a complement webinar to others provided here on this YouTube channel. Hello everyone. Today I'm going to talk a little bit about Reliability Center Maintenance and the culture evolution that is either in place or is missing in terms of a successful Reliability Center maintenance culture. We could talk, and I will at another time, perhaps, in terms of how you prepare for reliability with emerging trends and asset management technology and those trends, how we could deal with that. But for now, I just want to talk about Reliability Center Maintenance, or RCM, if you like, and the culture evolution. So here we go. As I said, we're going to talk a little bit about Reliability Center Maintenance and the culture evolution of that. And with that in mind, we will change the page. Topics we're going to cover today is what asset intensive companies want, the traditional value of asset management, how one sees value in that, some of the traditional truths and things that are missing, some of the traditional gaps, if you like, as well, that go with those truths, foundational reliability culture. So there's lots of people that say, hey, we have an RCM culture, but we're not really doing RCM. So what does that mean? And what does that mean for the future? We're going to talk about asset failure characteristics and operating context, if you're right, or operational context that you have to consider for RCM. We're going to talk about the decision flows and outcomes and data outputs that you might have to consider when you're doing your RCM analysis. In other words, what data do I get as a result of having done an RCM analysis? And what data am I missing if I don't do the RCM analysis? And I start thinking in terms of, well, we have a reliability culture. We don't really need to do the RCM work per se because it feels onerous. And what are the next steps? How can IT and IoT help? And a summary of the things that we just talked about, the summary of the benefits. So that's what I hope to cover. This is a fairly short presentation, maybe 25 minutes is the intent. And so what is it that folks are looking for? So we polled a number of folks a few years back in terms of what it is they want. If you're a large organization, perhaps more than 100 maintenance folks, what are you looking for? And so asset intensive companies are looking to achieve return on asset. That's probably makes sense. We bought this asset. The asset is trying to, well, is intended to make value or create value. That's why we bought it. We want to make sure that the asset continues to be available to create that value. So we want to reduce the consequence of asset failure, whether that be a safety, environmental, or operational impact or non-operational impact. We want to predict and mitigate conditions and behaviors that lead to asset failure. And we want to create and leverage asset-related data. So let's capture the data that we need to do that. And no doubt, as you might guess, and let's go get more data. So that, in a nutshell, is what the executives were looking for even, 5-6 years ago or more. What's the traditional value of asset management? Well, we all look to create value from our assets. So if this is my asset, there's my supply chain. And basically, I'm looking to create value from this series of things that make up my supply chain. So it could be a series of assets. And how do I do that? Well, I need to do that with, well, good operations, of course, operational excellence, but I also need to support it with maintenance and support it with parts, support it with procurement, because maintenance can't do its job without parts. Parts can't do its job without procurement. And somebody has to pay the bills. So procurement can't do their job without accounts payable. All these things have to work together. Unfortunately, one of the fundamental truths is that the data that one uses to do operational excellence or create the production is not necessarily the data and systems, if you like, that you use to support maintenance. And so often, if those systems aren't in the same platform, you're going to have issues where the data is simply not available to do some key KPI things, key performance indicator things, such as production volume versus maintenance cost or maintenance activity or those kinds of things. And so there needs to be a bit of an understanding as to how we can blend this data together. There also needs to be an understanding as to how we can create the proper KPIs. And the other reality is that the KPIs at the executive level are going to be quite different than the KPIs for the middle management versus the KPIs needed for the maintenance tech or the supervisor versus the KPIs at the asset itself. The other consideration is that when you look at all the way that an asset can fail, all the ways that an asset can fail, especially complex asset, typically about 11% of those components are things that fail over time. So if you look at this little graph, set of graphics on the right-hand side here, you've got a bathtub curve, you've got another curve where it's random over time and then starts to go up. You have failure curve or characteristic curve C, which basically says the probability of failure goes up somewhat linearly over time. But those things typically on a complex asset only represent about 11% of the failures, or component failures of a complex asset. The rest of them, generally speaking, are going to be random over time. And so you have 89% of the things that fail randomly over time, the components of the asset. And how do I get a handle on those? Well, the only way you can get a handle on that is to get some early indication of failure. And so you need to find a way to understand, how can I get that early indication of failure for the 89% of the components that might fail randomly over time. So there's a notion here where it says warning time on this lower right-hand chart. That's really what they call the potential failed state to fully failed state. That warning time is the P to F curve for signs of trouble to fully failed state. And in that time, if it's a fairly reasonably lengthy time, i.e. the first indication of failure is now and the fully failed states maybe 3 months from now, then you have an opportunity to perhaps organize some way of getting early indication of failure before it fully fails. On the other hand, if that P to F curve is something like the time of an incandescent light bulb, where it goes an ink pink and the light bulb's burned out, then chances are you don't have a good P to F curve, and you need to think about other methods in terms of how you might deal with that. So the traditional value of asset management, as I said, there's your operational value chain, if you like. And typically we apply enterprise asset management or computerized maintenance management systems to execute the actual maintenance, if you like, or to manage the execution of the actual maintenance. And with that, we might have the asset hierarchies. We would also have the we would have the parts requirements. We would have the KPIs in there, anything to do with the operational things that we need to do, along with the workflows. But all those things are in place to help us be efficient with our maintenance execution. At no time do we actually consider or have a database for the things that might help us pick the right maintenance to do, the effective thing to do. So typically, deciding the effective thing to do is a discipline called reliability-centered maintenance. Now, in another presentation, I'll talk about where I might fulfill that box and say that's really where asset performance management data goes. But for the sake of this discussion, I'm going to say basically the effective maintenance is this discipline called reliability-centered maintenance. So as you look through that, you say, well, what is a reliability culture? Well, without having done an RCM analysis, a reliability culture is, hey, we all got together, we're trying to do our best. We're trying to create an asset data baseline health metric. We may identify the bad actors and assets and address what they are. We may create defect elimination teams to try and sort that out. We're going to perform lessons learned on recent urgent critical outages. We're going to challenge our current tactics and maintenance plans and solve that where it makes sense. Review backlogs, encourage empowered employees, create a total productive maintenance kind of set of activities and culture, and challenge missed scheduled activities. So if we do that, yeah, I would say if you're doing all that, chances are you do have a bit of a reliability culture. Chances are you would suggest you have a very good reliability culture. But if you haven't done if you haven't done the RCM analysis, then to some degree you're doing as best you can without having done the work. So how do you bridge that? Bridging the foundational approach to asset reliability and reliability-centered maintenance suggests that you might want to put together a team, identify the critical assets for risk and reliability assessments, create reliability teams with maintenance operations and design engineering, calibrate the standards through training for the reliability teams of RCM methods and introduction, create facilitators of RCM for your company, review a few pilots after you've done a few pilots. So pilot a few reliability analysis with full failure modes effects analysis and review what they look like, and create a knowledge database and related data to identify the best tactic for each asset in its operating context. Create the thresholds that you might recognize are needed to flag actions. Now that frankly comes out more in an RCM3 than an RCM2, but you can do it in an RCM2 analysis. And document the reliability data and tactic plans in your EAM solution, and obviously get management to sign off on it. That's the formal RCM program. Now, having done that, you can see that with what we do on the right, you have a lot more insight and data than you might have if you were only doing the things on the left. So I'm suggesting you need to do both and sort out how you might sort that. Now, what is an RCM analysis and how do you do it? What's the approach? Well, generally speaking, it takes 6 folks. It takes all of them trained on the RCM practices. You need a facilitator, you need a maintainer and an operator and their supervisors, and you need some sort of subject matter expert. And with that, they would sort out what the asset operating context is. In other words, is it a pump acting alone, or is it like as in pump A here, or is it a pump that is acting as a primary pump with a backup pump, in this case, B and C? So you need to understand that. You need to know why I have it. So I have this maybe to pump 300 liters a minute. That's my primary function. The secondary function could be, and I don't want it to leak. What are the failed states? All the different ways the pump could fail. So it's not giving me 300 liters a minute, or perhaps it's simply not pumping at all. So it could be something like that. Failure modes effects analysis, all the things that could be potentially influencing the failed state. And so you look at the frequency, the severity, the impact, whether there's any health, safety, environmental issues, operator awareness, early warnings, predictability, and the list goes on. You can see that list there. And what's the consequence? Once we understand the failure modes effects analysis, is this actually a safety, environmental, operational, or non-operational impact kind of thing? And then with that, how do we actually mitigate the business risk, if you like, and the technical risk, the safety risk? And we pick something that is technically feasible and worth doing. And the only outcomes are going to be that it's something that you can predict, prevent, run to fail, therefore you're going to repair it after it fails, inspect, or redesign. That's really all it is. And perhaps if it's a very critical asset, or it's going to have a severe safety or environmental outcome, then you might do some combination of those things. And then ultimately, you're going to have this data, and you're going to understand how to describe the solutions and understand how you could align the asset and the risk prioritizations for both frequency and assignment and risk weighting and work order based things and that kind of stuff, and support your requirements, understand what tools I need, what training I need, what folks I need, what are the safety, what are the parts and procurement requirements. So if we do that, the outcomes, again, just simply stated, are one of 5 things: predictive maintenance, preventive maintenance, failure finding tasks, which are really inspections, no scheduled maintenance, which is really run to fail, or a one-time change, which is really redesign. And along with that and the data you have, now you're starting to get something that looks like a killer app. We've done the RCM, we have some data, and now we need to think about, well, how could we apply that data? So we've got this base culture, we have the foundational reliability habits, we've got the RCM things that we've talked about, none of the words have changed that we talked about before. Now, how do we actually apply this in an IT and IoT enabled reliability business and execute it? Well, one thing is you can integrate the asset health, transaction, and reliability threshold data. You can include market demands and other external data like like weather to influence asset maintenance schedules. You can prepare to leverage IT and artificial intelligence and machine learning to automate a first pass of an RCM analysis. Now, that's a little bit of a controversial topic, but let me just qualify it this way. We know that folks are using machine learning and AI to read all the medical journals to get a better handle on how they can deal with and identify cancer. Why could we not do the same process for at least a first pass of understanding what the RCM analysis options could be, and then let your team of 6 people go and curate that data to make sure it's right for them for that operating context? So there's a lot of opportunities there to think through when technology starts to come on board, which frankly is here. We just need to engage it. So, and we can also support a reliability culture that is automated to drive asset value through strategic operational optimization. So those are the things that we could do. Now, another way to present that same data is to look at it this way. At the foundation, we have the culture. None of these words have changed from what I talked about before. We have that foundational reliability culture, and we're basically doing the things that we said before. As I said, that's a nice list. Chances are even the folks that would argue they have a good foundational reliability culture are not really doing those things either, or at least not all of them. How can we add it? Well, we could add RCM, but it felt onerous. We're not sure we want to do it, but there's the same steps I suggested before. We need to do it. And one of the big issues is why. It feels onerous. I don't want to do it. We tried it once. We didn't implement it well. It wasn't a good use of our time. Well, the reality is, if you know the journey and where you're going with it, you're going to be creating data that you can automate with a good IT and IoT enabled reliability culture. And so that makes both the foundational reliability culture and the reliability center maintenance culture a prerequisite to get to something that can be automated. I've already talked about how you could integrate that and potentially automate it, or already talked about how you might use some of the technology to give a first pass, even though that is perceived to be a very controversial concept. And then with that, wouldn't it be nice, and wouldn't it be the killer app to bring in your data scientists once you've got this culture in place to kind of really look at things and say, confirm asset operating context, to confirm failure modes effects data, and take advantage of those things and find other issues that we might be able to predict, mitigate tactics and thresholds, or confirm them, those kinds of things, and mitigate them in an automated way, and then automate that in such a way that you can actually go back to your EAM system and drive automated work orders, automated inspections, automated repairs, those kinds of things. And that would be something that could be done in a nanosecond, instead of being very, very dependent on certain reports to come out and somebody interpreting the reports and then determining that maybe we need to go do some failure modes effects analysis or root cause analysis or automated repair. What would the benefits be? Well, I would argue that the benefits are going to be immense, but let's be a little conservative and suggest the benefits are going to be at least what the reliability center maintenance folks would suggest you would get. And that's to improve productivity, to increase maintenance effectiveness, and to reduce your costs of your business. Now, it's very, very clear that you really can't do that without a good IT support structure to have them come along with you. And with that, that's really what I wanted to share with you at this time. If you have any questions, give me a call, send me an email. I'd be happy to discuss it with you. You've been watching a webinar called Reliability Centered Maintenance Culture Evolution from Don Berry of Asset Acumen Consulting. This webinar was intended to be a complement webinar to others provided here on this YouTube channel. To contact Don, you can reach him at donmberry@assetacumen.com. Thank you for watching.